Hello everyone, Ranjit this side. So in this video, we'll be going through some of the statistical functions in SQL. These functions we use on the daily basis being a data analyst, and some of them we don't use it very frequently, but sometimes it does help us to make decisions, or let's say to further write down the query to get more relevant data when it comes to the business need. Most commonly used statistical functions, which will include sum, average, variance, and then we have variance estimator, then we have standard deviation, and then its estimator, or let's say standard deviation estimator. One of the most common used is of course a sum function. Sum function basically sum of a column returns the algebraic sum of all the values in that particular column. But what we have to make sure is that all the values in that particular column needs to be a number. Otherwise, it will not sum. So for an example, if you are saving or if you have characters or let's say string in that particular column, then it will not sum, right? For that, what you can do is you can convert that particular column to, or let's say a particular string into a number, or let's say digit or integer, decimal, or let's say a real data type, right? So let's try that, and then we can go with the second function. This is a server that we have. We are connecting with the locally installed server, and then we are connecting it. So the database that we were using earlier was financial data, and then we have tables over here, right? And then select here and click on new query. So now, since we have selected this database and clicked on new query, we will have the financial data database as a default database. Now let's select this table. So for that, let's say the select star from this table 5, or let's say you can execute, right? Now what we can do, let's sum it. So what we will be doing, we'll be summing the price. So let's say sum of price, and then this will give us the total sum. But here, if you see, we do not have any column name because we haven't given any alias. So let's say as sum of price, right? So now if you see, we have the column name as well over here. Let me just recap it. So this is how you can sum up the values. Here, what you can also do, maybe you can round this up because it's a very big sum. So just to make sure the visibility of the value, what you can do, you can use a round function, and then here you can say you need to round 2 decimal places. So now you have 0.64, right? So again, the round function will round up and it will not round down. So for that, you have to be very specific what you want to do with the round function. Anyways, so this is one of the most common, most frequently used function in SQL, which is sum function. Now, the second one is the average function. So in SQL, the average function is the algebraic sum of all the values in the column divided by the number of rows, right? So for an example, suppose, so for to calculate an average, let's say you have 5, 10, or let me just clean this up. So you know how the calculation is done for the average, but I just want to give you an example. So for let's say you have column A, and then you have 5, you have 10, and then you have 15. So these are the let's say the rows that you have in the database, right? So how the average is done, basically average will be equal to 5 plus 10 plus 15 divided by 3. So this is how the calculation or the average is calculated. Right. So in the same way, we will be doing in the SQL as well. So let me show you that. We can do it over here itself. So for an example, so here we can create or let's say calculate average. So for the average part, we can say AVG, and then we can give the column name. So again, and say price as average of price, right? So now if you notice over here, it's the average price of the overall data. But now let's say you would like to see the data based on the sector, right? So for an example, now you want the average as well as the sum of the prices based on the sector. So for that, what we can do, we can say group by, and then let's say the sector part, right? So for that, now you have the sum price. So since we have done this based on the sector level, So now we have, or let me show you the sector as well. Otherwise, how will you understand, right? So sector, the sum and the average should be based on the sector level. So what we have done, we have given the sector as the column name, and then we have done the group by as well. Right now you have miscellaneous. Let me order it as well. Order by one. So basically order by one is the one first column, right? So now you have first column as well. So for the ascending part, you don't need to mention whether it's an ascending or descending. You can, the default is the ascending part. Now, one more thing, maybe we can try is basically like we did over here. First, let's round it up, because see, when you do the average, most of the time, or let's say you will get the average as many decimal places, right? So let's round it first so that we can reduce the number of decimal places. Round. So we are doing the round to 2 decimal places, right? Now we have average, this one. Now again, so this is more of like, now it's very much clear, or let's say the data is much better to be understandable. A function is basically a variance, it's how the variance is calculated. So like I said, there are some of the functions which are not very used, or which are not used very frequently. I would say variance is one of that functions, but it's really powerful. So it's basically a way of measuring how the spread of the data is, with the existing data itself. And then we have two types of functions which almost looks like, or which basically calculates the variance. One is VARP or VARP. So like I said, the first is the first is VAR, right? And then we have VARP, right? VARP. Now, VARP basically it calculates variance with the existing data, right? Existing data. And then basically VAR is more like it creates an estimation of the variance. Most of the time we will be using VAR functions, because this is more of let's say, you can depend on the VAR function, but not very much on the VAR function, right? So let me show you the formula. So let's say, I'm really sorry with my writing because I'm not really good with the writing. So let's say VA, but somewhere someone has to start it, right? Okay. So the VARP, which is the variance, the calculation of variance with the existing data itself. So basically, what it says is we pass the column name, and then it sums up from I is equal to 1 to n, and then we have x of I minus average of the column, right? Square divided by, we have n. So what is this x? X is basically is the ith cell, or let's say the number of columns that we have. So this with the increment of I, the value of I also will increase over here, right? And which is the column number. And then n is the number of rows in the column name. So basically this is the total number of rows, and then I is the value of ith column name, right? So if we have, let's say, I is equal to, or total number of rows as 10, and then since we are iterating from I is equal to 1 to n, so whatever the value of I is at that particular point of time will be the xi. Now let's try it on the SQL part as well. Let us do somewhere first over here, and then maybe we can do in the main SQL. So let me just comment this. So control KC, right? So average, or not average, path, and then we have price from, let me just copy it. I do not want to write it again. And then this is the overall variant or variance of the price, right? So let's say we as far, you cannot you cannot give the function name as a alias name. So let's say price, right? So this is the one, and then let's group it by as well. So I would say sector, right? And then group by sector as well. Let's group by sector. So this is the VAR price, right? Now let's calculate the VAR as well. So VAR is almost the same as we had VARP, right? The only difference is, let me show you that as well. I is equal to 1 to n, and then you have x of I minus average of column square, sorry, and then here you have n minus 1. So since we have n minus 1, so the VAR will always be greater, and this is why we are saying that, you know, it's in mostly it's a variance estimator. But like I said, do not depend on this. Careful with the VAR function, because most of the time you will be using the VAR only. I'll give you an example where we can exactly use this. So for that, before that, let's calculate the VAR as well. So yeah, here you can copy this one, and then you can say var, and that's it. So you have our price and you have our price. I don't like having many decimal places, so for that, what we can do, we can do round, and then I want it to be a 2 decimal places, and then the same goes with var as well, right? And comma 2, and this is how you can create the var. So let's just copy this and take it up, right, so that we can use it with the previous ones. So to uncomment the code, or let's say the query, you can see kc or ku, right? uh, okay, so here I will add somewhere over here. So now if you see, we have the sum price, average price, var price, and var price. Now, why do we, what is the difference between the var price and the VARP is something maybe you should understand. So for an example, let's say you want to know the variance of the water consumption per household in your city, but you have the data for only, let's say, one district, right? The function VARP will calculate for you the variance of your existing data. The same goes for the standard deviation and the standard deviation estimator as well. So let me just make it a bit more kind of understandable. Okay, so now what we'll be doing, we'll be working on standard deviation. So the standard deviation is STD. Standard deviation is again the price, right? I'll show you what it does, or I'll come back to what it does basically. So as, let's say, STD, let's first run this, and then yeah, so again it has too many decimal places though, so let's round it, and then 2. So this is a standard deviation price, and then we have standard deviation estimator as well, predictor, sorry. So it's the predictor, and then we have price, right, as STDEVP, and then let's round it up, round, comma 2 as predictor. Now let's run this. So we have sum, average, var price, standard price, and standard prediction price. Now, what is the difference between standard deviation and standard deviation predictor, and then what are the relations between all these four? Let me show you it with the formula itself, because then you will understand. Okay, so we have STD is equal to VARP, which was the calculation that we did earlier, VARP, and then the column name, right? So this is how the standard deviation predictor is calculated, and then we have STDEV, which is more of like square root of VAR and the column name, right? So these are the two formulas which are basically, so now if you see, the VARP is rated with the standard deviation predictor, and then we have VAR, which is more like the deviation. So like I said, these are more of the ones used. The standard deviation is more commonly used for statistics, for understanding the distribution of the data, right? So how the data is distributed. The function standard deviation P is, it basically returns the standard deviation of your data, while the standard deviation def function returns an estimator like the variance was doing earlier. So this standard deviation def returns an estimator of the standard deviation of the data you could have if you continue to collect the data, right? But in some cases, the standard deviation or let's say standard def function is trying to predict the standard deviation for all the possible values of the variable, right? Sometimes you will hear that the standard deviation is more of a biased, or and then standard deviation predictor is more unbiased standard deviation estimator. So let's say this is a biased, or you will get more of a biased data when it comes to the standard deviation, and this is more of unbiased data. So I would say this data is more of like, it creates the data, or let's say it creates the report as it is, the standard deviation of the data that we have, unless you really want to create a predictor, but or let's say the estimator, which is I would not recommend to use this, but use this one if possible. So yeah, so we have already calculated all these statistical functions, and then you can surely see how it can be utilized in your profile, or let's say in your day-to-day job, right? So thank you so much. Have a great day. Take care.